Let's see another medium level problem from LeetCode. It's called unique paths, and this problem can be solved in many techniques. I'm going to show you using recursion and dynamic programming, and also using the DP array. First, try to understand this problem, and then we'll write the code for this. So there is a starting position and there is a end position on this two-dimensional array, and we need to find out total unique way we can reach from here to this place, start to end. So if you try to find the unique paths, then we are allowed to go to the right or the bottom. So that's the two way only we can move. We can move this way or we can move the down. So, and in this way we need to find out what are the total ways to reach here. Like if you reach here, like this is the one way, another way again from here to here, another way. So that's we need to find out. So what if you use recursion, then what we do, from like in order to reach here, we need to find out total way to reach this cell and this cell, and if you can add this, then we can reach here. And if you want to find out like what is the way to reach here, then we need to find out the way to reach here and this here, and then in this way we can add this and we can reach here. So that's the way we are going to use for using like DP and the recursion, and we'll use that and we can find this way. So let's write this code first, and then we'll use the DP array also. Okay, so from here we start from here, and we just go back, so we can do this. So let's do like so if I start from here and go back, then sometimes if my row will be 0 or the column will be 0. So that is our base condition. So if you reach here, in that case we can just say there is just one way to reach this place, because every cell has at least one way to reach there. So that's why I can write the base condition if m is equal to 0 or n is equal to 0, then I can say return 1. And otherwise I can call this function recursively, this function, and then I can say m and n minus 1 plus m minus this function, and then m minus 1 plus n. So that's the easy solutions here. So unique paths m, so we are fixing like from here, if you say from this place, we are fixing m, that is that's a row here, and then we're saying okay n minus 1, that is the column. So we go from here, and then here in this place we are changing the row, like this row, and the column will be same. And in this way we are just trying to find out from here what is the total count to reach here and what is the total count to reach here, and in this way we go recursively and we can reach here. So that is the solution. Let's run this. Wrong answer. Let's see. Expected 28. So m 0 or n 0. If it is m or n, anything is 0, then we can, yeah, but in this case, if you see this m is like, let's say the example for like 3 by 3, so m will be 3 here. So we need to because if I say it's a 3 grid and the 3 is a rows, then it should be 0 1 2, right? Like the 3, then we can yeah. So for that, yeah, I can reduce. I want to just reduce by 1, or I can just, if I want to start with 3 itself, then I can make it 1 here. So that's way I can do. Saying time limit exits, because we need to use a memoization technique, because some of the path we have already calculated and we want to return the result. Like, let's say if you want to come here in this or this place, so maybe we can come, if you start from here, so we can come here, and in this way this place, and from this place again we can come to this place, or we can come to this place. If you come to from here to here, this place, this cell is already calculated, and so if it is already calculated, we can return the result. So that's, for that we can use the memoization. So let me call this function here, like, and I just need the helper function. So in this way you can say this is the helper, and we are calling from this place. Then I can easily call this function here, and now I can check with the M0 or original way, and in this way I can, while calling the this, I can just say last index m-1 and then n-1, that is this last index. And I need to store the result. So for that I can say I can create one variable dp and some make it's a map, key is int, or I can say key is a string and value is int. I can pass this dp, some map, string and int, and in this place this is our result, and this result I want to store for m and n, because when the m and n for some cell value, if it is already calculated, just return that. So for that I'm just creating one key. So key is for the m and n, m comma n. Yeah, so for the m is integer, just I want to make one string, so in that way I can use the both of the values, so that I make the string, and that's the key, and this is our result. And I can return the result, and I can store the result here. So in our dp, so dp and the key, and key is a result, and if this result is already calculated, then return the result. So here I will check that. I'll check inside the dp, I'll check the key, and this is the value, and okay, if it exists, so if okay, then return v. So that's the way of using the memoization, and we have done many problems in previous videos about this memoization. So I guess you know those things. So I will run this time. Memory limit exits, let's see, we got the m and n, so this is the key, and if you the dp key, if it exists, okay, then we can return the v. So that's good. And dp key, we are storing the result. So this memoization is not helping. Maybe let's try m and n. I put this, or key each. Where is our key? We have prepared the m and n. Let me call this place, and that is our key. You can see here. Okay. Oh no, so I think this is fine. You can key use here also, but the problem is here we are calling something different. So call the same function and just pass this dp. Okay, so that's the way to solve using the recursion and dynamic programming. Let's see another approach. So I'm just going to comment this, and this is approach 1. And this is comment this line also. And another way, this is called approach 2. Here we are approach 2, here we'll use the dp array. So when we use the dp array, what we do, we create the dp array of the same size, and in the same size we first initialize each block with 1, because we know there is a one way to reach the cell, and then we traverse each cell here. And if I come here, I want to, so first I will initialize with 1, and then next time when I traverse, I will traverse with I1, that is row 1, and in the column 1, like from here. And if I come here, then I see if I see like what is the total ways to reach here, then I will add this value and this value. So in this way, again, when I go to the next next place, then here again we'll see what is the way to reach here and what is the way to reach here, and we can just add up this thing, and in this way finally we can reach here and we can return this column, this cell value over there. So that's I'm going to do. So for that, let me create first the dp array, and dp array is make it's a two-dimensional array. It's a type int, and the size is length of this m. So, and now next thing is we initialize this. So I will use for I is equal to 0, I less than m, I plus plus, and then for each row we need to also create for each row we need single dimensional array also. So we need to initialize that also. So because we say that we created two-dimensional array where we created each row, but we have not mentioned like how many columns in each row. So that's what I'm going to create here. So dp I is equal to make, and then int, and this length of, that's the n, that's the column, and we created this, and then we need to initialize each box. So now I can say for j is equal to 0 and j less than n, j plus plus, and each box we just initialize with 1. So dp I j and initialize with 1. Okay, so first time we initialize 1. Now we start with I1 and J1, and then we can utilize previous result and just move forward. So just I will copy this whole code, put it here. I will just remove this, and I want to start with 1 and J also with 1, and dp ij is dp I j minus 1 plus dp I minus 1 and j, and that's what the simple logic. And in this way we'll reach here and we'll just add up this previous result to the next cell and then return the value of the next the last cell. So return dp, that's m minus 1 and n minus 1, and we have called unique okay, that's the unique paths. And this approach 2, we're not calling any additional functions, but we're just this dp array technique we're utilizing. Run this, accept it, submit. Okay, that's the another better solution. So that's all for now. Thank you.